the n square first order partial derivatives. What kind of partial derivative? Del x bar I by del x I. Del x j. This is j. Okay. Del x bar j. Okay. So that means you differentiate this with respect to xj component. Partial derivative studied in your third semester. Okay. So this partial derivative. How many partial derivatives will be there? There will be n square partial derivative. Okay, see, for example, suppose it is like this. I tell you, you have two equations. Let me change color. Suppose you have two equations. X bar 1 equal to x bar 1 of x1, x2. Okay, and x bar 2 is equal to x bar 2 of x1, x2. So what will be the, here there will be two square partial derivatives. What are they? Four partial derivatives. One is del x bar 1 by del x1, del x bar 1 by del x2, del x bar 2 by del x1, del x bar 2 del x. So this much partial derivatives I can generate from this. Okay. So there are two square, four partial derivatives. So for this equation, n components are there. So there will be n such components. So what will be that? Del x bar 1 by del x1, del x bar 1 by del x2, etc. Del x bar 1 by del xn. Similarly for del x bar 2, etc. Del x bar. So you will get a, if you put it in the form of a matrix, you will have a matrix having n square components. That's the idea. So this obtained from the above from transformation 1 are normally arranged in the form of an n cross n matrix. And that matrix I usually call it as J, that is equal to, first will be del x bar by del x1, del x1, del x bar 1, del x2, etc. Del x bar 1 del xn. Please bear with me with this bad this handwriting, because I changed the computer and some adjustment problems. Okay. So del x, I am speaking so you can understand what I am writing. Del x bar 2. So along with me you write, then there will not be any problem. By del x1, del x bar 2 by del x2, etc. Del x bar 2 by del xn, del xn, etc. So it will go to this. And here I have del x bar n by del x1, del x bar n del x2. etc. 1 second. Okay, sorry for this. So I just so this matrix n cross n matrix. The last one will be del x bar n by del x. Okay, so this matrix. So here also left side comes this matrix. So this we got. So this is called the Jacobian matrix. Okay, the name given to it is, this is called the Jacobian matrix. The matrix J, the matrix J is called the Jacobian matrix. Jacobian matrix, and its determinant determinant. Okay, how you write that determinant? You can call it as det J. Okay, its determinant is called the Jacobian of the Jacobian of the transformation of the transformation. Okay, so this is called the determinant. This determinant is usually called the Jacobian, and if you are writing as a matrix, you include Jacobian matrix, you will say. If you are merely saying that Jacobian, that means that the determinant. Okay, now I just tell you an example. What is the meaning of this one? For example, we take this example. Let me go to here. In R2, 2 dimension. Okay, in R2. In R2, let a curvilinear coordinate, let a curvilinear coordinates xi or x bar I be defined from coordinates xi x bar I. So this is xi is one coordinate system. The bar this one is another coordinate system. By the equations, x bar 1 is equal to x1 x2, then x bar 2 is equal to x2 square. So nonlinear transformations here. Okay, so it's a kind of affine. Then you I want to find out the Jacobian. Okay. So what is the Jacobian? Find the Jacobian. Find the Jacobian of transformation. Of transformation. Find the Jacobian of transformation. So what do you need? You need the partial derivatives. Okay. You need the partial derivative. So I write that del x bar 1 by del x1 you need. Okay. So first वाला del x1 से तो आपको क्या मिलेगा? x2 मिलेगा. Then del x bar x1 bar by del x2. तो क्या आएगा? So this is equal to x1 है with respect to x. Del x bar 2 by del x1. तो क्या आएगा? वो 0 आएगा because in the second transformation there is no x1. And del x bar 2 by del x2. So this is 2 times x2. 2 times x2. x2 का coordinate का square. So 2 times x2. So this is. So what is my Jacobian? So the Jacobian of transformation, so I can say, therefore, the Jacobian of transformation is transformation the Jacobian of transformation is, okay, what will be that? You put it in the form of a matrix. Determinant J is equal to, it should be this determinant, del x bar 1 by del x1, del x bar 1 del x2, del x bar 2 by del x1, del x bar 2 del x. Okay, so it will be this. So this is nothing but determinant. First is x2. X square नहीं ले लेंगे. It is x2 means it's a coordinate. It's not the square of x. ऐसा नहीं. Then this is x1. This is 0. And this is 2x. So this is the determinant. And what is this? This is equal to this cross. Okay. So this is 2 times x2 square. Don't write it x raised to 4. So this you should take care. 2x2. So this is the Jacobian of transformation. So this is that. Now, I write a note. Okay, so in the note I want to say, see, suppose x is equal to r cos theta. X is equal to r cos theta and y is equal to r sin theta. Then what you do? You find out r is equal to square root of x square plus y square and theta is equal to tan inverse y by x. So now you look to this one. And this is this transformation. So what is this? If r and theta are given, r and theta, they are given, then how will you find out x and y? This is the meaning. X and y. Here what is that? If x and y are given, how will you find out r and theta? So if you look to this one, These are inverse processes. These two are inverse processes. If a transformation is given, that is r and theta are given, then how will you find out x and y? Here, if x and y are given, how will you find out r and? So they are reverse process, so they are inverse process. Okay, so if this transformation is given, I can find out this one. Now the natural question is that for all kind of such transformation, can we find out such a thing? The inverse transformation is possible for all type of transformations. Okay, so for all types of transformation, it is not possible. That is what I want to say. And then for what kind of transformation, what should be the condition that is to be satisfied if the inverse exists? Inverse to exist. Okay, so this is what I am going to write in this note. Okay. Okay. So this note I will just. So what should be the condition? If the transformation 1, if the transformation 1, okay, you know what that transformation is 1 1 and on 2 is 1 to 1, 1 to 1 and on 2. You have studied 1 to 1 mapping and on 2 mapping, isn't it? On a open set U, on a open set U of Rn. So it's a subset of R. Okay. Then determinant J not equal to 0 and converse. Okay, so this says that if your mapping is 1 1 and on 2, 1 1 mapping and on 2 mapping, then you can always find the inverse. Okay, so that is why if the mapping is 1 1 and on 2, the result is that determinant of this will never become 0. If determinant is not equal to 0, it will be 1 1 and on 2. And if the mapping is 1 1 and on 2, you can find out the inverse of the transformation. So this is the idea. So in order to say that your inverse transformation you can find out, then you have to show that your determinant J, that is Jacobian, should not be equal to 0. In this example, which we have described here, that is the situation. You take the Jacobian of that, you can see that it never becomes 0. So that is why you should be able to write the inverse of that. So in this case, the inverse of the transformation, this transformation 1, inverse of the transformation 1 exists and can be written as xi is equal to xi of x bar 1, x bar 2, x bar. Okay, I 1 less than or equal to I less than or equal to So अब देखो फर्स्ट इक्वेशन का जस्ट रिवर्स आ गया. फर्स्ट में क्या था, x bar I equal to x bar I of x1 x2 etc etc. So it's the reverse. So this transformation you are finding out xi in terms of xi bar. So it is a reverse transformation. So further we have j into j bar. What is j? J is the Jacobian for the original transformation. J bar kya hai? For this transformation. Okay, so that will be equal to j bar j, which will be equal to I. So if you take the Jacobian of the original transformation, Jacobian of the inverse transformation, if you multiply those matrices, you will get an identity matrix. Okay, so that what you can say, determinant of j. You take determinant on both sides, determinant j bar. So that should be equal to determinant of I. What is determinant of I? What is the determinant of unit matrix?
1.
1. So this is 1. So I can say that determinant of j is equal to 1 by determinant of j bar. This is it. Okay. So if the transformation to exist, we have to have this condition. Okay, so the product of the determinant is equal to I, equal to 1. Okay, so and one determinant is nothing but the reciprocal of the other determinant. Okay, so now this much background we needed for entering into the idea of tensors, because tensors deal with the transformation quantities which are invariant under coordinate transformation. So let me come to that. I write what is the first order tensors. We start very simple tensors, first order tensors. And you should understand the geometric meaning and the meaning of that tensor. Then only, otherwise then it will be always confusing to you. So let me have the first side with you. First order tensors. First order tensors. First order tensors. Okay. Let me define. Consider a vector field. Consider a vector field. Vector field V equal to Vi. Okay, V equal to Vi. So what do you mean by that? It's a vector space is having, what are the members? They are vectors. Vector field means that. Okay, so vector field, so it will take at different points different values, these vectors. Okay, see, for example, vector field, I want to, you have studied actually the vector field in the, see, for example, I am writing a vector. Okay, V is equal to X, 1, Y, okay, something like this. Then what happens? This will take different, the length of this vector will be different at different points. For example, suppose I am looking to the origin. Origin में ये vector क्या होगा? V will be 0, 1, 0. Suppose I am looking to the point 1, 1, 1. Then what is this vector? This vector will be 1, 1, 1. Okay. So if I take another point, the value will change. So vector will change. So the vector which takes different values at different points constitute a vector field. So I am considering this vector field. V equal to Vi. So by which you mean that you are considering a set of vectors, whose value will depend on the point. Okay, I'm considering this. Defined on some subset S of R. N-dimensional space का subset में I am defining this. Where Vi, what is Vi? Vi means Vi of x1, x2, etc. So this is the meaning of vector field. I am saying that it's a vector field. That means that it will be a function of the coordinates. Vi, the components of the vector will depend on the coordinates x1, x2, etc. Yes, that's the meaning. So that's why it's called a vector field. Is a scalar valued function. Is a scalar valued function. Scalar valued function over S. Okay, each component will be a scalar. See, आप इसका number, each component देखो. It's a scalar valued function. So this is your V1. ये component को क्या बोलते हैं? V1. ये component को V2. ये component V2. So its value will be a number at a point. So that's why it's called a scalar value. The n components. What are the n components? V1, V2, etc. Vn. V1, V2, etc. Vn can be expressed as n real valued functions as T1, T2, etc. Tn in the xi system. Okay, so V1 I denote it by T1, V2 I denote by T2, etc. Vn I denote by Tn. And T bar 1, T bar 2, etc. T bar n in the x bar I system. These are coordinates, two coordinate systems. Okay, where how these systems are, these coordinate systems are related. That is what. Where xi and x bar I. Okay, so they are related by x bar I is equal to x bar I of x1, x2, etc. xn and xi is equal to xi of x bar 1. This is the inverse transformation. X bar 2, etc. X bar n. Okay, so this will be our fundamental, for defining it, this will be our fundamental thing. Okay, so you have a vector's components you are in xi system is given by this, and in x bar I system is given by this. The transformations are this. Okay, then you can define what is called a contravariant tensor. Okay, so now write the heading contravariant tensor. Contravariant tensor. Okay, what's that? The vector field V is a contravariant tensor, is a contravariant tensor of order 1 of rank 1, or in other words we can say order 1. Both are correct. Order 1. Provided its components. What are its components? One is Ti and T bar I. Ti and T bar I. Relative to respective coordinates. Respective coordinates. What are those coordinates? Ti will be in xi coordinate system, and it will be in x bar I coordinate system. Okay? Obey the law of transformation. Obey the law of transformation. Law of transformation. T bar I. Let me write it with a different color. T bar I. That is equal to TR del x bar I by del xr. 1 less than or equal to I less than or equal to. Okay, so this is oh. It is something problematic. Okay, so look to this one. This transformation law. If the components are transforming like this, in one coordinate system, it is T bar. So this is in one coordinate system. This is in the xi coordinate system. Then when you go to x bar coordinate system, x bar I coordinate system, I will get this component. So how I get this component? Multiply this component by del x bar I by del xr. Okay, then the component I get. So any quantity which is transforming in this form is called a contravariant vector, a contravariant tensor. Okay, so if you look to this one, what is actually this? I tell you, so many things are here. See, if I have this one, let me take more. Okay, so let me take from this, I is equal to 1. So what is that? T bar 1, okay, is equal to T r del x bar 1 del x bar 1 by del x r. So if I is equal to 1, I will get this. But you know, this is by Einstein summation convention. What is this? This is T1 del x bar 1 by del x1, first component, first term, T2 del x bar 1 by del x2 plus etc. nth component Tn del x bar 1 by del xn. So when I write like this, for I equal to 1, I am getting this component, T bar 1 is given. So T bar 1 depends on all other Ti's. T bar 1 depends on all other T1, T2, etc. Ti. Remember that. So this is the meaning of T bar. Similarly, you can write T bar 2. T bar 2 क्या होगा? इधर 2 आएगा, इधर 2 आएगा. So you will get a similar thing. T bar n भी कर सकते हैं, इधर आएगा n आएगा, इधर n आएगा. A quantity which is transforming according to this law, we call it as a contravariant tensor. Okay, so there is another type of tensor, what is called covariant tensor. Then after defining this also, we say that what will be the difference between these two and how geometrically you have to interpret this. Okay, so a tensor of this kind of rank, this is a vector. I will say that this is a vector. And tensor of rank 2, this is rank 1. Rank 2, you say that should be matrix. Okay, so there is a then there will be a contravariant vector, a covariant vector. But you have studied only one vector which is having magnitude and direction. That is called a vector. That is what definition you have studied. Now, that is true. That is true. But there are two types of vectors. So that is something which will be new to you. Okay, and how to interpret these vectors in terms of their components, that is the thing which we are going to discuss it in the next class. Okay, so initially you may feel little difficult, that's okay, but you try to understand this, attend it carefully and ask me questions. You should ask so many questions, but nobody is asking questions, that's the problem. Okay, so then you will understand it clearly. So I will describe it with my maximum ability, but you try to understand that. Okay, so we will stop it here. The time is almost near. Okay, if anything you want to ask, you can ask me now. Otherwise, we will stop. Okay. Okay, thank you.
Hello, sir. Hello.
बोलिए.
Hello, sir. Exam will be offline or online, sir?
Oh, that is not yet decided. I think if it is going like this, it will be online, and at the 1 or 2 months, then what is the situation? It all depends on that situation. So university will declare it. We cannot say anything.
Okay.
Because we don't have any.
Okay, sir.
Okay.
सर
Okay.
एग्जाम मई में होगी ना?
हाँ. Rajveer, you want to say something?
यस एग्जाम मई महीने में होगी ना? तब तो ऑफलाइन ही
I
होगी.
think most probably in May. You
तब तो
will
ऑफलाइन.
be informed in advance. No problem. Okay.